Welcome back to Transformations.
I should have you do it one day.
In this Holcombe's class.
Seth, will you do it one day? Oh, okay. All right. Transformations.
Go Ohio State.
Yep. Go Vols. Transformations. We did translations yesterday. It is simply sliding right, left, up, or down. You have to think of where positive and negative numbers are to determine if you're going right, left, up, or down. We looked at the Delta Math assignment, had you calculate the point after a translation. Then it had you look at a graph of a pre-image and an image and state what the translation was, right? So how do you feel about translations? Okay. Because we will have a quiz Monday at the end of class. I was going to say tomorrow, but that's a little early. We will have a quiz Monday at the end of class that will cover translations and reflections, okay? Which brings us to reflections, which is when you are flipping the image over some type of line. Let me give you a roadmap of this. We have 4 types of reflections. We have flipping over the x-axis. I'm turning the page. We have flipping over the y-axis. We have flipping over a random horizontal line anywhere on the graph, anywhere. We have flipping over a random vertical line. And then we have the last 2, which we will save for tomorrow, when you are reflecting over the line y equals x and the line y equals negative x. Now I said 4 because over the x and the y-axis, I would call those like there are 2 different axes, but it's the same technique, you're just counting. Over a random horizontal or vertical line, you have to look at the picture and count it. And then over the lines y equals x and y equals negative x, there's a rule, which means there's a formula. Okay, let's start back here. You're going to love this, and I'm not being sarcastic. We are going to reflect this pre-image over the x-axis. So I want you to imagine, right, you got your 4 quadrants. If something is on the left and I'm going over the x-axis, so let's say it's over here in quadrant 2. This is quadrant 2. If it's in the quadrant 2 and I'm reflecting over the x-axis, which runs right here, y'all with me? Yeah. Oh, I didn't draw that good. But there's the x-axis. Where's it going to land? Which direction is it going to go? It's going to go down. So if you start to graph this and your shape's over here, you should know something's wrong. Because it's just flipping down, right? Now, I want you to think of wet ink. First of all, draw your dotted line right there. I want you to think of wet ink. Like this shape has just been drawn in a in a magic marker that bleeds. You know what I mean? So you know how those pens, you have to sometimes let them dry before you close a book or something. Okay, imagine this has just been drawn in a pen that has to dry. The ink is wet. If I close the book right along this line of reflection, this is the line of symmetry, it's going to land down here somewhere. Do you agree? Don't draw that though. But do you agree?
Yes.
Now you know where it should land. Now it's a matter of just counting it. You're literally counting it. So watch. D is, this is why it helps to draw your line of reflection. D is 1 away, so count 1 below. Now count A. 1, 2, 3, 4 to to the line of reflection, so count 4 past it. 1, 2, 3, 4. B is 1, 2, 3, 4, so 1, 2, 3, 4. C is 1 away, so 1 over.
I remember.
Of course, now it helps to label. Now, instead of sitting here and reading those points, ask yourself, it was up here, right? And it flipped down. So the Y value had a change in sign. Does that make sense?
Yeah.
So if you look right here, you see this? That is the written rule to represent a reflection over the x-axis. If you think about it, it was up here, it flipped down, so the x's are all the same. It's the y value where you no longer went up, you went down. And so there's a negative in front of the y. The negative means change the sign. Doesn't mean negate, doesn't mean make it negative. It means change the sign. So by making it negative, sometimes it might actually become positive. So right here, my formula is negative y. All these y coordinates will have a sign change, which in this case, because it was up in quadrant 2, they all come out what? Negative. Then there's your points.
It's just little.
Yeah.
That's what it is, huh?
If it's going, let's take some notes. If it's going over the x-axis, y changes sign, which is why this right here is the written rule. It's very important that you know this is the written rule. So I don't know if you want to write it again, that the rule would be x comma negative y. That's the rule. Now let's go to the next one and try it.
I feel like the x-axis is going to change on this one.
Think about it. If it's over here, and I'm flipping over the y-axis, it's going that way, which means the sign of the x-coordinate changes. Yes.
It's just
Same concept, it's just now instead of up, down, it's going left, right. So, find your line of reflection, and then count. So, B is 2 away, so 2 past. A is 4 away. Wherever that point is 7 away. Be in line with it, right?
That's,
Is that E?
yeah.
D is 6 away. C is 3 away. Okay. Wait, I'm going to purposefully do something wrong because I want to stress to y'all. Alright. Let's say I was going through it and I got sidetracked, talked to somebody, came back, and I started drawing my shape. How do I know something's wrong?
Because it ain't the same shape.
It should be the exact same shape, exact same size, okay? Those are the only things we're working on right now. They all are the same shape and size. So if you are going through this and something doesn't match like that, you know you've done it wrong. It does help to label your coordinates. Remember, you're using C prime, or the prime sign, I'm sorry. Now here, we're going over the y-axis, which means the rule would be a sign change on x. So all of these x's get a sign change.
Is it not easier to do that first than what it would?
Sure. This is a, to each his own. However you find it easier. All right. I'm going to call that done, and there will be a delta map of just reflecting over the X and Y, okay?
For homework?
It is not homework, it is your practice that you could complete in Flex tomorrow.